Physics, and this is my experiment over the nuclear bomb and just how it works. So I wanted to do this presentation a little bit like we do our other experiments, since we didn't actually do a regular experiment this week. We didn't do anything hands-on, so I wanted to make it kind of similar to how we do our other ones. So what is needed? You'll need natural uranium, LEU, which is low enriched uranium, HEU, which is highly enriched uranium, MOX, which is a mixed plutonium-uranium oxide, and just regular plutonium. So what is nuclear fission? So nuclear fission occurs when a heavy atom splits into lighter and smaller nuclei. The excess energy is then released. Sometimes nuclear fission can be induced from the outside, or it can just happen spontaneously. But when the neutron shoots at the nucleus, it then gets absorbed by the nucleus and the fission occurs. Sometimes, though, when the special elements such as isotopes of uranium and plutonium, the excess neutrons can be released during the fission, which causes the chain reaction to trigger and then to be absorbed by the atoms that are nearby or close by. This is a picture of nuclear fission happening. As you can see, it starts with one, and then the unstable nucleus breaks, and energy and the excess neutrons are then released. Okay, so what is nuclear fusion? So nuclear fusion is basically nuclear fission, but in reverse. The lightweight nuclei will sometimes fuse together and form the heavier nuclei. But if the pressure or temperature is too high, it then releases the energy in the process. So as you can see in this picture, this is nuclear fusion happening, and this fusion breaks down into releasing the energy and the neutron. What fuels this nuclear bomb? In a nuclear bomb, the only elements with isotopes that can go through fission, which is also described as variations of the same element with different number of neutrons in the nucleus, but the most common isotopes used in the nuclear weapons are always plutonium-239 and uranium-235. So how does a nuclear bomb really work? So critical mass must be constituted, and critical mass is the minimum amount of nuclear material that is required for fission to maintain. Each piece is not enough on its own, but if you collide the pieces, the fission chain reaction can occur because the critical mass was reached. So as you can see in this picture, I have the critical mass and then what subcritical mass means, and subcritical mass comes in the next slide. So how does a nuclear bomb work continued? Well, modern nuclear weapons work slightly different. Critical mass depends on the density of the material, and as the density increases, the critical mass always decreases. Instead of colliding the two subcritical pieces of nuclear fuel, modern weapons detonate chemical explosives around the subcritical sphere, or also referred to as the pit, of uranium-235 and plutonium-239. The force from the blast is directed inward, compressing the pit and bringing its atoms closer together. But once it's dense enough to reach the critical mass, the neutrons are injected, initiating a fission chain reaction and producing an atomic explosion. In fusion weapons, also called thermonuclear or hydrogen weapons, the energy from the initial fission explosion is used then to fuse the hydrogen isotopes together. That energy released by the weapon creates a fireball that reaches several tens of millions degrees, which is also close to in the same range as the sun, which also runs on fusion. So, a pure fission primary is inefficient, but the plutonium pit will blow itself apart before most of the plutonium-239 can fission. Instead, the reaction can be boosted by including the hydrogen gas consisting of the isotopes deuterium and tritium in the center of the hollow pit. But as the surrounding plutonium fissions, the hydrogen gas undergoes fusion and releases neutrons, including additional fission. Similarly, the secondary doesn't consist purely of fusion fuel. Layered within its fission spark plug, consisting of either plutonium-239 or uranium-235, as the primary explosion compresses the fuel from the outside, the spark plug material becomes supercritical and fissions, heating the hydrogen from the inside and facilitating further fusion. So fusion releases neutrons, but these neutrons hit the layer of uranium surrounding the fusion fuel, causing the atoms in it to fission. This fissioning generally contributes more than half of the weapon's total explosive yield. Thermonuclear weapons that don't include the uranium blanket are also called neutron bombs, as the neutrons freed by fusion are released from the weapon. Neutron bombs therefore create a larger amount of radiation than a normal weapon of the same yield. And these are the sources plus the video you gave us on Cambit.